Alright everybody, hello, my name is Austin Flannery. I'm a meteorologist with the National Weather Service Tampa Bay Area Weather Forecast Office. We cover West Central and Southwest Florida. Myself and Dustin Norman put together this presentation about CoCoRaHS. So if you've been following our social media accounts at all the last month or so, you've probably seen a lot of posts about it. And that's because we're right now in the middle of our recruiting season, if you will, for this program. We're trying to encourage as many people to join as possible. And what exactly is it and why is it important to us? Well, that's what we're going to talk about today, because the reality of it is it's extremely simple how you can help us, but it's very, very important to our overall mission. So what is CoCoRaHS? It's the Community Cooperative Rain, Hail, and Snow Network. Okay, so the snow part's probably a little funny to most of you who've lived in Florida for any length of time, because it doesn't snow very often in Florida. It can happen, it has happened, but it's a rare thing. Nevertheless, it's there because CoCoRaHS is not just a local thing. This is really an initiative on a beyond just even the United States. It's an initiative for the entire Northern Hemisphere. It basically comprises a network of thousands of volunteers from across the Northern Hemisphere that take daily rainfall measurements to kind of give us a snapshot of what's going on in terms of rainfall. And this data is extremely important to us for a lot of reasons. The National Weather Service only has so many instruments, and you guys get to kind of help us fill in those gaps by contributing to this through this network. So we definitely are encouraging you all to learn more about that, and hopefully we can kind of share some of those insights with you today. CoCoRaHS was founded in 1998 at the Colorado Climate Center from Colorado State University. And it came about in part because of an event that took place the previous July in Fort Collins. There was a specific rainstorm that basically, or a system I should say, that dumped 14.5 inches of rain on the region in the span of 31 hours. 14.5 inches is a lot of rain, even for Florida. But it's compounded in a place like Colorado by things like the geography and the geology. Because where Fort Collins is located, you have elevation, so changes in the landscape that kind of cause water to funnel. But the soil is also not the same as Florida, where we have a soil that's very good at absorbing moisture and water that falls. They have a soil that can handle a decent amount, but that level of rainfall is too much for really any soil. And ultimately what this amounted to is a major flash flood that went through Fort Collins. And unfortunately, 5 people were killed in a mobile home park. And ultimately, this kind of had to reshape the way that the city thought about flood mitigation. And they had to take a lot of drastic steps from that point onward to make sure that they were prepared for a situation like that in the future. So at the time that that event occurred, no such network like CoCoRaHS existed in the United States. So the only way that the National Weather Service could get weather observations like as far as rainfall goes was through networks that had previously been set up by the National Weather Service. And while they're good, they're lacking in a lot of ways, and there's many gaps, and especially at that time there was a lot of gaps. So CoCoRaHS then came about to kind of help fill those gaps and provide a better snapshot of what's going on for the future, so that a situation like this could hopefully be avoided from taking place again. So what started out as just kind of a regional initiative has morphed into what it is today, and it's actually this broad scale national initiative, and going beyond, like mentioned earlier, to kind of collect rainfall data from around the country and the Northern Hemisphere so that it can be utilized in the forecast process to kind of understand what has already happened, to better prepare for what will take place. And, you know, CoCoRaHS has been around now for just a little over 20 years, So it's impressive to see how far it's come in a relatively short amount of time. And it's exciting to see where it will continue to go. Now, this data is extremely useful beyond just the National Weather Service. Of course, we use it. It's very important for us. At the Florida level, some of the more frequently used, and people who use it more frequently like ourselves, it's going to be used by folks within the emergency management community, whether that's county emergency managers or state level emergency managers. It's important to understand flood risk. So for them, that data is extremely important for mitigation purposes and understanding that. Southwest Florida Water Management District is another one of our partners that use it very frequently. They're kind of tasked with managing water across West Central and Southwest Florida. They track water levels in a lot of the rivers, and they control water releases from areas where water is controlled. And this data is important for them, understanding how much rain has fallen within the river basins that they manage. Looking at other agencies within the federal government that use it, the Department of Agriculture certainly cares a lot about rainfall from a perspective of understanding how that could affect crops. A number of them are very sensitive to rainfall. Too much or too little could destroy a crop. As far as they're concerned, that's important to understand then how much rain is falling. And also the U.S. Geologic Survey uses this data because like SWIFTMUD, so Southwest Florida Water Management District, USGS kind of looks at, as part of their job, they monitor river and water levels as well. And for them, it's important to also understand how that's changing. Now, the people who use it, they'll go beyond just that, those individuals. It really is a large list of people, from private weather companies that use the data to kind of understand how much rain has fallen and to improve their forecasts. Insurance adjusters use it when it comes to trying to understand, flooding, if a home was flooded or not, kind of understanding how much rain fell. And a lot of other people use it as well, including teachers and students. We can't forget about them. That's extremely important for them. It's a teaching tool. So this data is extremely important for a lot of reasons beyond just what we use it for. But something I haven't really touched on yet is exactly how we use it. In particular, it provides us ground truth to what we're seeing. So obviously we have things like radar and satellite, and even some models, right? They can provide us estimates of rainfall. But it's not an exact science, especially in a place like Florida during the summertime. Rainfall is highly variable, and even more specifically, highly variable over a small space. So what CoCoRaHS observers do for us is they kind of help us fill in those gaps that exist just because of the nature of summertime weather in Florida. So it's important for us to be able to kind of understand that on a smaller scale. As I've mentioned before too, we have observation networks across the state. We do have weather instruments set up. We have at airports, there's a number of airports that we have weather instruments at that we collect data from. We also have a network of what we call cooperative observers. They're separate from CoCoRaHS, but they also collect, among other things, rainfall data. But CoCoRaHS provides us a much higher density way, so we can have a lot more observers across spaces to really start to see the more finer details in how rainfall totals are changing across the entire state and beyond. So I kind of mentioned the whole ground truth aspect of what CoCoRaHS can do for us. This is a snapshot of a 24-hour period of rainfall back from, if this date sticks out at all to you, it's from Tropical Storm Nestor back in October of last year. So the map here, if you kind of look at some different places, so if you look at Pinellas County, so the St. Pete area, you look at the extreme western portion of the county right along the coast, you see some areas of like a deeper orange color. That's anywhere from 4 to 6 inches of rain that fell in that area based on this estimate. However, that's a pretty significant contrast to, say, Central Highlands County, where Sebring is located, for instance. where parts of the county there were only estimated to have between 1 and 1.5 inches of rain. So over a relatively small distance, the rainfall varies quite dramatically, even in a situation like a tropical storm, where one would almost expect the rain to be more in uniform type of distribution. So it would look more uniform across the entire region. And it even then has variation in that. Now, we could also go into how Nestor was a more unique type system and such, but the point is, it just goes to show that rainfall is variable even in a situation where you don't necessarily expect it to be as variable. To kind of hit this point home, this is a more extreme case. This is from May 3rd of 2014. Basically what took place was a frontal system stalled over Tampa Bay. So basically it was a weak cold front that basically completely ran out of steam and just came to a screeching halt over Tampa Bay. And that led to what we would call a training type situation. So when you're talking about training, if you think about if you've ever come up to a railroad crossing and there's a train that's coming and the gates go down and then a real long freight train comes through and it feels like you're just sitting there forever watching this train go by, well, if you think about it like that, it's kind of the same idea of what we're talking about here. Basically what took place is a line of thunderstorms parked over that spot along the boundary there, along that frontal system, and it just meant that they kept dumping and dumping and dumping rain over one spot. So the image on the left is an image of our total storm accumulation of rainfall. So basically, from when it started raining to when it stopped raining, the radar was tracking how much rain it thinks fell. So notice the area that's kind of highlighted there. 6 to 10 inches is what was estimated. So we knew it was raining very heavily in that area. And of course, we responded accordingly with warnings and such to highlight how that area was seeing so much rain. Reports from places like CoCoRaHS allowed us to verify that that was indeed correct. So I highlighted a couple in the image on the right. This is a snippet from our public information statement, basically kind of highlighting how much rain fell across Hillsborough County. A little to the northeast of Tampa, there was a report of over 9 inches of rain. But meanwhile, a little bit further back to the south and west in Town and Country, only 1.4 inches of rain fell. That's a massive spread over a short distance. So CoCoRaHS helps us to see the ground truth in what we're seeing on radar. And this is extremely important, certainly in an extreme event like this where we see a lot of rain in a short amount of time. You may have seen this graphic on social media before. We've shown it before. This just kind of highlights, again, why some of this is important and where some of those gaps exist. So the image on the left there kind of shows you the Withlacoochee watershed, right? This is basically a river basin following the Withlacoochee River that runs kind of through our northern areas here. We would like to have a better idea of how much rain is falling in that river basin so we can more appropriately communicate with our partners like SwiftMud so that they can take the appropriate actions to mitigate any potential flood hazards. There are portions along the Withlacoochee River that SwiftMud controls the water releases from, and they do this depending on how much rain has fallen and how much rain they expect to fall. So we can give them an idea relatively easily of how much rain we expect to fall, but it can be more challenging to actually show how much rain has fallen, especially if you look at, in the images on the right of Sumter and Levy specifically, there's really no observations in those areas. So it becomes difficult for us to go beyond just using our tools that, as I've mentioned, estimate, and for the most part estimate well, how much rain has fallen. But we can't really provide the ground truth for it. So CoCoRaHS observers help us with that. And it's not just in the Withlacoochee watershed that that's important. It can be in other places like DeSoto County, which of course, is a relatively sparsely populated area, but we would still like to know what's going on in that region so that we can better understand how much rain falls. It's important for us to be able to do this. So the final thing, of course, that everybody wants to know is who can participate. The simple answer is anyone. Whether you're young or old, anyone and everyone can participate in CoCoRaHS. And it can be what you make of it. The reality of it, though, is you are contributing to a better understanding of the weather that goes on here in Florida and beyond. You're making a difference in and improving our ability to forecast the weather. So one of the initiatives and the vision of the National Weather Service is to build a weather-ready nation. And part of that is understanding and better predicting the impacts of water as it relates to, talking about rainfall specifically, right? We want to better understand how that is affecting our communities. And this is how you can really help us, is by joining in this program. And there's a lot of materials available to you to make this a really interactive event. If you're a teacher and you've got students, there are lesson plans available. There's some different sorts of questions that you can ask your students and get them thinking about things. Even if you're just curious, you're a weather enthusiast, you've always wanted to know more about weather or help out and learn how you can do more, this is a way you can do that. So I would encourage you, if you don't know a lot about this, to definitely try and learn more. Visit the website, which is just CoCoRaHS.org, okay? So it's the same acronym that you see on the screen, and just add .org on the end. So go out there and visit the website and take a look at the information and see if it's something you'd be interested in getting involved with. It doesn't take much. Really, all you're going to need is a simple rain gauge. And Dustin's going to talk some more, though, about that and kind of what the potential pitfalls can be sometimes for people who hop into this, and also kind of share a little bit more insight into why it's so important. So with that, I'm going to turn it over to Dustin.
Thanks, Austin. Hi, everyone. This is Dustin Norman, meteorologist at the National Weather Service office in Tampa Bay. So some of the things I want to talk to you today are about common mistakes that people make with reporting, and as well as placing your rain gauge in the proper location. So first things first, deciding what gauge to use. Automated rain gauges are great and they're very useful in their purpose. However, when it comes to getting precise rainfall measurements, they have their shortfalls. Tipping buckets, for instance, measure rain by water falling in this little seesaw device down at the bottom that's designed and calibrated to measure 1/100th of an inch at a time, and then it tips and then it repeats itself. So what occurs is that if we have a torrential downpour, which we oftentimes have in the summertime here in Florida, it can actually underestimate the total rainfall because as it's tipping, it's not counting the rain. So if we have a heavy downpour, it's going to underestimate the rain. So to counter that, one of the optimal things to use is a good old-fashioned manual rain gauge. And the photo on the right is our standard 4-inch manual rain gauge that you can purchase on CoCoRaHS' website. This rain gauge is incredibly accurate, and it's actually determined to be just as accurate as the standard 8-inch rain gauge that we use for our National Weather Service Office's Cooperative Observer Program. So it's incredibly accurate, and we advise anybody who is going to be submitting reports through CoCoRaHS to purchase and use one of these rain gauges instead of your home weather station. However, before you go out and sign up for CoCoRaHS and buy a rain gauge, make sure you have a suitable site. Ask yourself a few questions. Do I live in an apartment or condo? If so, am I going to have an appropriate clearing and distance in order to set up a rain gauge and get accurate measurements? The other thing would be, do I live in an urban area and have little property or no property with large buildings around? If so, am I able to place the rain gauge on the roof to get an accurate measurement? And I'll talk about this in a couple of minutes. The other thing would be heavily wooded areas around my house. Do I have an open area where I can place my rain gauge? If there's too many trees around, that's not going to be good. And one of the less obvious restrictions would be my HOA. Does my HOA allow me to post a rain gauge up on my fence or on a post in the middle of my backyard? So ask yourself these few questions, and if you end up having a good, nice open area, which I'll discuss some guidelines to follow here in a second, then I can go ahead and buy my 4-inch CoCoRaHS rain gauge. Okay, so you've determined that a rain gauge is appropriate at your site. So you go out and buy one. Now, where do I want to place it? Ideally, a rain gauge should be placed twice the distance as the height of the obstruction. So an example of that would be the rain gauge should be placed 60 feet away from a 30-foot tall oak tree. Now, realistically, that's not always possible, especially in suburban areas. I know in my area near Tampa, that's going to be very difficult to find. So a compromise is to place the rain gauge at least the equivalent height away from the obstruction. So if the obstruction is 30 feet tall, we would like to at least keep the rain gauge 30 feet away from that tree. So an obstruction could be a house, it could be shrubs, it could be a large tree, etc. So in this example here that you see down in this picture, although conveniently placed because I just walk right out my door and take a measurement, it's too close to the house, and that is going to prevent accurate wind measurements, especially when you have wind blowing from the house towards the rain gauge. Now, this example is a little tricky because you may think, okay, I'm placing it on the side of a fence. I'm going to get really good accurate measurements. There's no obstructions. I'm good. Well, think about what the wind, if you have a strong wind blowing in a thunderstorm, what happens to that wind as it hits that fence? It's going to rise over the fence and then come back down the other side. And what that does is actually create a little miniature updraft that can actually inhibit rain from going into the rain gauge. So you could actually get a low measurement. So we want to avoid placing our rain gauge on the side of a solid fence. Preferably, we would like to place it on the picture on the right on a post. However, be sure to bevel the post, which a bevel just means angle the cut of the post so that rain does not hit the top of the post and splash into the rain gauge. As long as you have the rain gauge placed high enough up on the post where rain's not going to splatter into the rain gauge, you don't need to bevel it. But if you're placing it right at the level of the top of the post, you want to make sure that you bevel it away from the post or from the rain gauge. So here are a few examples of different types of terrain or urbanization that we could experience. So on the left you have a residential, which is likely the most common for one of you guys measuring rainfall for the CoCoRaHS network. Again, this is a good example. We have a clearing, we're not too close to fences, we're not too close to trees, we're up on a post, the rain gauge is high enough up on the post where it didn't need to be bevel. Now the middle photo is urban, and I mentioned this earlier where an apartment complex is not a good example. However, if your apartment complex happens to allow you access to your roof, or let's say a condo or even an office building, access to the roof, feel free to place a rain gauge up on top of this. Now on the right side we have rural. This is obviously the most optimal example of an accurate rain gauge. We have a clear open field, a beveled post. We're going to get phenomenal measurements here. The little pad that you see is a hail pad, which is also part of the CoCoRaHS network. Because we're not out in the Midwest and we don't regularly get large softball size hail, that's not typically a measurement that Florida CoCoRaHS users report. But if you're interested, feel free to purchase a hail pad and report it. Okay, so moving along to the importance of accuracy, and I think this is one of the most important topics that we can discuss. Remember that the data that you're providing are often consumed and used by scientists, and scientists really love accurate measurements, and we don't really like to round things. So this rain gauge is accurate to 100th of an inch. So on the example on the left, there's 0.26 inches of water in the rain gauge. Please do not round this down to 0.25 inches or round up to 0.30 inches. We want to make sure we're reporting as accurate as possible, because that could mean the difference of rainfall, daily rainfall record for your county. Also, be sure to report zeros. It may not seem like zeros are important, but for drought monitoring, they really are. And as of this recording, which is on March 30th, we haven't really had any rain in most of the Tampa Bay area and Southwest Florida. So we are increasing our drought potential, but without zeros, we don't have any direct physical evidence of that occurring. Also, report traces. So what is a trace of rainfall? A trace of rainfall is anything less than 100th of an inch. An example of this is if I'm walking outside on an afternoon and I get a few sprinkles of rain. Doesn't have to be much, just a few sprinkles. I want to record that as a trace tomorrow morning's report. Even if when I go out and check the rain gauge, it's bone dry. If a few drops of rain fell, record it as a trace. Okay, in these next two slides, I'm going to show you how to properly measure your CoCoRaHS rain gauge. Oftentimes in Florida, and I can guarantee this will happen to you at least once this summer, you're going to receive more than 1 inch of rain. Well, what happens when you get more than 1 inch of rain? Because the inner tube only measures 1 inch. The additional rainfall is going to overflow into the outer tube. So the inner tube can hold 1 inch, or 1.00 inches to be precise, and the outer tube can hold an approximately 10 additional inches. So your entire rain gauge can hold 11 inches of precipitation before it overflows. Hopefully you're not going to have a completely overflown rain gauge, but that is possible in a tropical event or an extreme rainfall event where we would happen to get more than 11 inches in 24 hours. Very unlikely, but that is possible. And then in that case, you would just record that your rain gauge overflowed. So take a closer look at this picture, and you have the inner tube, and then you have the outer tube. So I will show you how to properly measure this when your rain gauge does overflow into the outer tube. Okay, so hopefully you can tell what's going on with these photos. They're not the best examples, but I did the best I could. First, carefully pull out the inner tube, measure it, and then pour it out. As long as no water falls out as you're carefully pulling it out, that should be 1 inch. But if water pours out into the outer tube, that's fine. But just make sure you measure what you're pouring out in the inner tube. Now, this is the tricky part. Place the inner tube on a hard surface and carefully pour the water, so you can put the funnel back on the inner tube. Pour the water or the contents from the outer tube into the inner tube. Make sure that the water does not tip or overflow. So this inner tube can tip very easily, and also as you're pouring, the water takes a little while to drain. So I've had examples or circumstances where water has definitely started to overflow on the inner tube, and I have to quickly make sure that doesn't happen. So that's step 2. Now what we're going to do is just repeat step 2 as needed. So if you have more than 2 inches, you're going to have to do this again. So just keep pouring the water into the inner tube, measuring it, and then pouring it out. Pour water into the inner tube, measure it, pour it out. And now what you're going to do is just add up all the measurements to the nearest hundredth of an inch. And that is going to be how you record more than 1 inch of rainfall in your CoCoRaHS rain gauge. All right, so when do I report my measurement? One of the most important things is to at least keep your measurements consistent. Now remember that these are measured as 24-hour rainfall totals. We're not going out there measuring hourly. We measure 24-hour totals. So try and avoid doing a measurement at 10 p.m. one night and then another measurement at 10 a.m. the next day, because that's only a 12-hour period. 7 a.m. is preferred and is really the standard for CoCoRaHS reporting. The reason for that is most hydrology models, most river forecast centers use 7 a.m. That's also when some bias corrections are used for radar estimates. So data is going to be utilized the best by all the partners of CoCoRaHS when we report at 7 a.m. However, anytime between 4:30 a.m. and 9:30 a.m. is acceptable. Other times are obviously accepted, as I mentioned previously, but they're not going to appear on the CoCoRaHS map, because the CoCoRaHS map is really showing a snapshot of the last 24 hours of rainfall across the country. And so the idea is to try and keep those times as close to one another as possible. However, I understand that some of you may not be able to record at 7 a.m., so just do the best you can, and the data is still going to get used, but just remember 7 a.m. if possible. That's the best optimal time to report. So what happens when I go out of town? Well, that's an excellent question on how to handle those rainfall measurements. There is an option in the CoCoRaHS form to label something as a multi-day accumulation. So I'll give you a couple examples of when you would use multi-day accumulation instead of the standard single-day accumulation. Example 1 would be, I last reported on Friday. I went out of town through Sunday, so I was gone through the entire weekend. Monday morning, I measure 1.54 inches of rain. Because I don't know if that rain fell Friday afternoon, Saturday morning, or Saturday overnight, I need to report that on Monday morning as a 3-day accumulation. So that would be from Friday to Saturday, Saturday to Sunday, Sunday to Monday. So that would be recorded as a 3-day accumulation, valid Monday morning of 1.54 inches. The second example would be that I last reported on Wednesday. My internet crashed. Hopefully that doesn't happen to you. So I can't access the CoCoRaHS site. The next following morning at 7 a.m., I measure 0.25 inches of rain. The next morning, Friday morning, I measured 0.54 inches of rain at 7 a.m. My internet came back on, fortunately, at 9 a.m. on Friday. What I'm going to do is I'm going to go into the system and I'm going to submit a 2-day accumulation report of 0.79 inches, which is just the sum of the 2 daily rainfall measurements I reported, at an observation time of 7 a.m. Friday. So even though if you enter it at 10 a.m., you can still put on there whatever time that you took the observation. And so it'll be a 0.79 inch accumulation, 2-day accumulation, valid at 7 a.m. Friday. All right, so this wraps up and concludes our presentation on the CoCoRaHS program, the importance of it, and some pitfalls to watch out for. On behalf of Austin and I, we really appreciate you guys tuning in and hope you have learned something. However, if you do have any questions, please feel free to reach out to either the state, regional, or local coordinators of CoCoRaHS. You can follow the URL that you see on the screen, and that will take you to a list of the email contact information and the names of all your coordinators. Austin and I are regional coordinators for West Coast of Florida, which spans from Lee up to Levy, and then out east to Polk and Highlands and Sumter County. So if you live in one of those counties, shoot us an email and ask us a question, and we will be happy to assist you. Hope everybody has a good day, and thank you again.